Hey everybody, this is Larry, this is Miko Q3 of the weekly contest 484 Count Caesar Cipher pairs. Hit the like button, subscribe button, join me on Discord, let me know what you think about this one. The first key idea about this one is that, if you have two words A and B, they're variables, A and B, if f of A, in this case where, we have this like cipher similar or whatever it's called, if f of A is equal to f of B, then f of B is equal to f of C, then f of A is equal to f of C, right? This transitive property. That's one. Then the thing after that, after noticing that's the case, that means that you can try to find, I call it a normalized version of the word, which can mean anything, which can, there are a lot of different ways to do it. What you want to normalize is that you want to find what we said about ABC, you want to find a C such that we just need to check how to convert from A to C, and then, that's it, right? And then the other, so for that property, we just want to be able to go from A to C, but then the other thing, of course, is that there's no false positive, right? Meaning that if you calculate this word C, it is unique to like everything that calculates to this word will give you the answer, right? Meaning that, for example, if you have just like, if every word maps to Larry, well, that's just going to give you a wrong answer because every word's kind of mapping to the same word, right? And then after that, it's just about this idea of I and J. N is going to be big, 10 to the 5th, so you cannot do N squared with or without O of L. Similarity check. Yeah, and that's basically the idea. And that idea I implement here. I think I did this very quickly, relatively. But yeah, so this is my normalization, right? For me, the way that I did is that I go, okay, well, if we make the first, because basically the entire string, you move everything one character at a time, right? Either up or down. I mean, I guess technically you can only move it up, I think. But you have unlimited number of operations, so then it just kind of loops around. So you have all 26 versions of this, including the one that you have. So when you have this visualization where you have 26 of these strings and they're all equivalent, then for me to normalize it, I just pick one of them. And for me, I just pick the one where it is A in the first character because everything kind of, is the same in the other way. And there are other ways that you can actually do this, by the way. But this is the way that I did it. For example, you could use another letter. I mean, that's obvious. But you can also just calculate the delta from the first character, right? Because then you're just up and down. Well, there's a lot of things you can do. But this is the way that I did it. I just calculated the delta from character A, and I just converted to A as the first character, and every character after that, depending on this delta. Yeah, and then after that, I just get, for every word, I calculate the normalization. I find how many things that we previously matched, which is what this is, and then add it to the sum, meaning that, okay, if we've seen this normalized word 5 times previously, that means that this new word that we just added can make 5 pairs, right? So that's kind of where this comes from. So, but it looks a little bit too simple, so you may not get that. If you do, fine, that's great too. And then we add one more so that in the future, if there's another word to normalize to the same word, you can get it matched up. And that's it. That's all. Yeah, this is going to be linear time-ish. I say ish, I mean, it's still linear, but it is actually O of n times L, where n is the number of word, L is the length of the string. But of course, that is still linear because that's the size of the input, right? The size of the input is just the sum of the lengths of all the characters of the words or something, right? So that's it. Yeah. But yeah, linear time. I want to say linear space, and that's it, because this thing can contain one copy of every word. Yeah, that's why I have this one. Let me know what you think, and you can watch me solve it live during the contest next. Silly. Okay. Computer's too slow right now, or browser. I mean, I don't know. We're at a point where my internet browser is too slow. Oh well. Q3. All right. Count Caesar Cipher pairs. S and T are similar if you have N words, M characters. Okay, fine. Choose S or T. Replace every letter in it to the next letter. Okay. Okay. Yeah, I mean that's straightforward, right? I mean, this is, yeah. Delta is equal to say root surface. Okay, so then now we subtract it from each character, right? C minus delta. And then let's mod that by 26. And then plus back A. Is that right? No, I mean, yeah. What's this? And then double check. Oh, I did not convert this back. Looks okay, right? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, take good mental health. I'll see y'all later. Take care. Bye-bye.